Good morning. Thank you, everybody, for staying here. We are going to take a look around the IMIP project. This is Salvador Gilabert, technical director of the project. IMIP project is an innovative eco-construction system based on interlocking modular insulation wood and cork-based panels in SUDOE region. SUDOE region means Spain, south of France, and Portugal. So I would like to explain you a little bit the results about the different systems that we have done, we have developed on the project, and its features. So first of all, we would like to introduce our kind of biodiversity. The South European forests are most of them in a Pinus pinaster and maritime pine, in between others species, but this one is one of the most common ones. And from that, we have to understand that the Pinus maritimus or Pinus pinaster wood is really fast growing up, and but with not really high performance. And that's because of, in history, is just for not really strong performance uses as pallets or envelopes. And we wanted to, with the new technology, to give this timber a really good performance, and to have a really much better uses in constructions. So for that, we wanted to, as an objective, to reevaluate a low performance good, designing uses and sectoral integration of construction systems with a really low environmental impact, with sustainable construction systems compatible in a high energy efficiency. Those systems will be reusable and recyclable in a construction systems. For that, we was focused to get a triple balance for developing all of these systems, taking care about the aspect of social balance, economic balance, and ecological balance. In that, we are working really deep inside of the circular economy. That means that this wood is a local wood that goes to a really local industry and is really able to implement it in a local system, construction system, buildings, renovations, industries, etc. So always taking care about the local circular economy and the way of life of the materials. For that, we are really focusing, taking care of the life cycle of the materials in the cradle to cradle. So our materials came from our forest and capture the CO2. They are really a really good stocker of CO2. And then at the end of the life, this is starting with the process again, because it came back to the nature and will contribute to the new contribution for the forest. So, and the development systems that we got in the project are the next that I would like to explain it to you and to show you. We were developing different systems for slabs, roof, and walls, and the possibility of partitions and or light roofs. For that, we have done an evolution of a really thin CLT, a composite CLT of 46 millimeters deep, that could be combined with insulation and different layers for create a partitions, a sandwich or a zip detail, and for developing different systems like roof or partitions. Then we have developed a CLT of 60 millimeters thick that will be involved in the other two different systems, like systems for roof and slabs, in a combination with different thickness of insulation and different thickness of CLT that can increase a lot the structure performance and the insulation performances. So with, and the last CLT that we developed is the 100 millimeter, but in fact, we can arrive with the same material to 120, even 140 millimeters thick of CLT with maritime pine. That means that with all of this combination, we can create a lot of different kind of systems according with the necessaries of the requirements in every construction project. The type D of this IMIP system consists in a CLT with insulation of natural cork that is also a really good performance insulation material, but a really high recyclable and with really low environmental impact material. So the combination gives us a really great performance in terms of structure and in terms of insulation with really low environmental impact, as we will see later. The type B for roof or even for some partitions is a SIP. It's a combination of two CLT layers of 45 or 46 millimeters thickness and 100 black cork board. This combination is really useful in order to achieve light covers or even some strong walls or partitions, and it's a really new combination because of the CLT 45 millimeters. Is a new composite that is especially good performance for fire in order to achieve the proper resistance that we will not be able to arrive with a regular CLT with this thickness. The third one is the type A, is for roof, is really strong slab for roofing, where we have 60 millimeters CLT plus ribs, and inside these boxes we are adding a granulated cork. It's really cheap cork because it comes from some wastage on the industry of the cork, of the natural cork, but again with a really high insulation performances and with really low environmental impact. The type numbers, the last one, the number 4, is the type C, is for slabs, for getting a good, really great structure performance, and is composed by two CLT layers of 60 millimeters, and in between we have some ribs and a granulated cork for getting the insulation of the requirements of in every different construction details. So the combination of all of these types, we can achieve a different construction systems, but from the roof, passing by the facades or envelopes or walls and partitions, and from slabs and structure systems. So the idea is that using the combination of these different IMIP systems, we can achieve the whole requirements of complete building or complete construction that we wanted to perform. That one, the one that we saw before, is our Portuguese pilot action that we will develop in another video on the program. And this one is the Valencian pilot action. It's a pilot action for testing different sustainable energies and renewable energies. And the combination here is a little bit different than the Portuguese one. We have here a really longer span of the roof and structure. That's why we can achieve different and higher performances details as the type A, C, and D for walls, for roof, slabs, and covers, always with our Pinus pinaster and the cork, natural cork. So with a really, really low environmental impact. So our performances of structure are really, really good enough for solving the regular problems in the construction. So the results of these details and systems is really an innovation in a low performance wood composite boards to achieve high performances. Construction system based on wood and natural cork compatible with the traditional systems, and optimization of parametric configuration systems to can achieve a different performances in order to achieve a different requirements for environmental or energy efficiency. And also we can analyze all this data in our app web that we will see in another video later. The performance of our systems have tested in a regular standards, and according to the standards, we have achieved with a really, really low performance wood as a C16 or C18, really good performance for structure support. As we can see, we can arrive to 3.5 meters with 100 millimeters thickness of CLT, but this will increase in the first step with if we can arrive to C20 or C24 timber, and that's why we are increasing a lot the uses of this kind of wood. In the type B, we can see as how the combination of the two CLTs of 45 millimeters composite, we can arrive to spans in order to 2 meters to 30 meters with 2 kilonewtons per square meters loads, and this is with a really low performance of the timber as a C16. So is with really low quality timber, we are achieving a really good system for the construction. If we go to the type A for roofing, we can see how we perfectly can arrive to 6 meters span in only 30 millimeters of total thick of the system. With type number 6, with the type C is our detail 4, with a combination of 2 CLT of 60 millimeters and ribs, we can arrive even to 8 meters of span, quite with a really low performance timber like the C16. So that means that we can achieve almost all the projects that we need with a really low environmental impact and with really good performance of the system. So if we have done the analysis of the CO2 emission, we can quantify the carbon emissions and the carbon sticks and the substitution effects that we can get from our systems. And if we do the comparison in between, for example, in the detail A, roofing, in comparison with a tile roof, like let's say traditional roof, we can see in the left side that we are almost 1/3 part of the CO2 emissions, or what means that we are really lower environmental impact in comparison with the traditional one. Not even as a impact, but also like a negative performance means that we are stacking the CO2. It's helping to clean our environment using these systems, because of we keep the CO2 or some emissions from the other or our industry or our way of life. But with these systems, our trees, or the trees that we are going to use for these systems, are stocked of CO2. The same happens with facades, as we can see, in comparison with a standard or traditional wall. Or the same happens with the flooring or slabs in comparison with a concrete floor. We are almost 5 times better in environmental, according to the CO2 emissions or CO2 stocks, in comparison with the traditional concrete floor for environmental impact. And if we can go through the analysis of energy efficiency, we can see how down in the passive buildings, our systems are down in this comparison. We are 4 times more efficient energy than a regular construction system, like concrete systems or brick or steel systems, calculated as a standard in the Código Técnico de Edificación, or as a standard that we were using all of these years. So our systems are much more environmental impact, have much more environmental impact efficiency and lower impact into the environment. It's much better performance in order to emit CO2 emissions, even working as a stock CO2. And in terms of energy efficiency, the buildings done by our systems have much better performance in energy efficiency than the regular ones. So we can achieve, and we were checking these results with our app web that we later on in another video we can explain, and analyzing even with the certificating, officially certificating in energy certifications like a Hulk and Ferma, and the data are recognized by the Spanish regular and standards. So also the environmental impact have done under the 5 more important indicators like the water, waste, energy, bioclimatic system, materials, and environmental impact. And the results we will explain you in a video of life cycle analysis that we have done of our systems. Just in order to make a little comparison, we can see that our system is the blue one in comparison with 3 other different states, like concrete one or steel one. The steel one is the red one, and the concrete one is the green one. So the environmental impacts are much more lower than the rest of the systems. So thank you so much. This is my email. If you have any question, if you want to contact us, and we will see you in the next video. Thank you. Bye-bye.